work done during adiabatic process. First of all, what is adiabatic process? A process in which pressure, volume and temperature changes, but there is a no transfer of heat. That process is known as the adiabatic process. For this, consider 1 mole of an ideal gas contained in an insulating cylinder fitted with a frictionless piston whose area of cross section is capital A. Let the volume of gas V exert pressure on the wall of this container, also on the piston. Due to this, gas expand and piston moves in upward direction. Let this piston moves through a distance, small distance dx. Then force acting on this piston is given by, we know that pressure is equal to force upon area. By rearranging this, we get force is equal to pressure into area. So here force acting on the piston is F is equal to PA. This is equation number 1. Here you can see when gas expand, then piston move upward direction through distance dx, and a force act on this piston. We know that when we apply a force and displacement occur, then there is a work done. So external work done by the gas is given by dW is equal to F dx, and this is equation number 2. Now we use the value of F from equation 1 and 2. We get dW equal to PA dx. Also we know that area multiply distance, that is volume. So here A dot dx equal to dV. So this becomes dW is equal to P dV. This is equation number 3. Now if the gas expand from initial volume V1 to final volume V2, then total work done can be calculated by integrating this equation 3 between the limits V is equal to V1 to V is equal to V2. So work done, this is equal to integration of dW equal to integration of dW is PdV, and limit is V1 to V2. What PV gamma equal to K for adiabatic process. So by rearranging this, we get P is equal to K over V gamma. Now we are going to use the value of P is equal to K over V gamma. Here we get integral V1 to V2. Instead of P, we write K over V gamma dV. Now this is equal to K is constant taken outside. Inside we left integration V1 to V2 dV over V gamma, and this can be written as K integration of V1 to V2 V gamma. If we take this numerator, it becomes V minus gamma dV. Now the integration of V minus gamma dV, this is equal to V minus gamma plus 1 over minus gamma plus 1. So this becomes K V minus gamma plus 1 over minus gamma plus 1, limit V1 to V2. Now we take minus gamma plus 1 outside. So here we get K over minus gamma plus 1, and inside we left V minus gamma plus 1 V1 to V2. This is equal to K. We can write this in this way 1 minus gamma. Now we put the value of upper limit, that is V2 here. So V2 minus gamma plus 1 and minus lower limit is V1, so it becomes V1 minus gamma plus 1, and this is equal to, now we multiply with k inside, we get 1 over 1 minus gamma k V2 minus gamma plus 1 minus k V1 minus gamma plus 1. So work done equal to 1 over 1 minus gamma k V2 minus gamma plus 1 minus k V1 minus gamma plus 1. Let this is question number 4. We know that P1 V1 gamma equal to P2 V2 gamma and equal to K for a adiabatic process. Now we put the value of K P2 V2 gamma here and here P1 V1 gamma. So this becomes, this is equal to 1 over 1 minus gamma P2 V2 gamma and V2 minus gamma plus 1 minus K. K here we put P1 V1 gamma V1 gamma minus gamma plus 1, and this is equal to 1 over 1 minus gamma. So here base are same, V2, then power are added. When we solve this, here gamma cancel with gamma, we have left with 1. So this becomes P2 V2 and here P1 V1, and this is equal to, if we take a minus taken outside here, then we get here becomes gamma minus 1 and P1 V1 minus P2 V2. This is question number 5. Let the temperature fall to T2 from T1 during the expansion. When gas expand, then temperature falls. Suppose it is fall from T1 to T2, then by using ideal gas equation, P1 V1 is equal to RT1 and P2 V2 is equal to RT2. So equation 5 becomes, work done, this is equal to 1 over gamma minus 1. Here P1 V1 we write RT1, and here instead of P2 V2 we write RT2. So this becomes, work done is equal to, here R taken outside over gamma minus 1, here T1 minus T2. So this is the expression for work done in case of adiabatic process.